Ratios and proportions. At the end of this lesson, you should be able to answer, how do I identify and solve real-life problems that can be solved using proportions? In order to answer this question, you will have to be able to identify a ratio. So let's establish what this is. It's simply a comparison of two quantities by division. Here's an example. The image shows the ratio of girls to boys in a daycare. According to the image, I spot 3 girls and 5 boys. There are 3 ways to write a ratio. The first 2 that you see on your screen are read the same way, 3 to 5. The third way is written in fraction form. Fraction form is one of the most common ways that we'll use it, especially because we'll be talking about proportions. Okay, so example 1 says a volleyball team plays 14 home matches and 10 away matches. Find the ratio of home to away matches. So you're just going to take your 2 numbers and write them in fraction form, 14 to 10, which reduces to 7 to 5. Now, find the ratio of home matches to all matches. You just got to be a little bit careful with your words. There are 14 home, and you have to add 10 and 14 together to get all of the matches. And 14 to 24 will reduce to 7 to 12. Now, let's establish what a proportion is. We know what a ratio is. It's simply an equality of 2 ratios, or one ratio or fraction equal to another fraction. So 1:3 as 5:15 is one way to read this proportion. And we know that 1/3 is equal to 5/15. But a key idea here is that in proportions, the cross products are equal. It means if I multiply on the diagonal, 1 times 15, that has to be equal to 3 times 5. And it is, because 15 equals 15. We're going to use this idea that cross products are equal to solve some proportions. 11 is to 6 as x is to 30. We're going to find our cross products, meaning take 6 times x, which is 6x, equals 11 times 30. And 11 times 30 is 330. And then I have a very simple algebraic equation. I divide each side by 6 to get the answer to this, so x is 55. Now, often students ask me, does it matter which product you do first when you are multiplying? It does not. Often kids like to do the one with the variable first, and that's fine. So 3h is equal to 12 times 17, which would be 204. And then again, divide each side by 3 to get an answer of h equals 68. And that's the value that would make this proportion true. Okay. Now, example 3 looks at some real-life scenarios. It says, a recipe for tomato salsa calls for 30 tomatoes to make 12 pints of salsa. How many tomatoes are needed to make 4 pints of salsa? Often, kids will look at this and maybe not recognize that a proportion is something you can use. Now, obviously you can because we're talking about proportions today, but here's how you spot it. There is a ratio mentioned here, tomatoes to pints of salsa. That's the key information. So what I'm going to do is set up a proportion paying attention to my units. I'm going to put tomatoes on the top and pints of salsa on the bottom. And it doesn't really matter. I could do it the other way around, but I decided to do it this way because it's the order it is in the problem. 30 tomatoes to 12 pints of salsa. How many tomatoes are needed? So we don't know this. I'm going to put an X in the tomato spot on the right side to make 4 pints of salsa. Now, the way of figuring it out is very easy. I'm going to find my cross product equation. So 12 times x is 12x, and 30 times 4 is 120. I solve by dividing by 12, and I get x equals 10. Therefore, it takes 10 tomatoes to make 4 pints of salsa. Okay. Another real-life application says Jeremy is uploading photos to Shutterfly, which is a website for printing pictures. The files are large, and his internet collection is running very slow. He uploads 8 photos in 15 minutes. At this rate, how long will it take him to upload 50 photos? Express your answer in hours and minutes. So again, how do I know that I can use a proportion? I spot a ratio, and it even tells you that it's a rate, which is a type of ratio. 8 photos to 15 minutes. So I'm deciding to put photos on the top and minutes on the bottom. 8 is to 15 as 50 needs to go on the top this time because it's photos. And how many minutes? I'm going to call that m. So I find my cross product equation, which would be 8m equals 15 times 50 would be 750. And to solve it, I divide each side by 8. So m would equal 93.75, and the label on this would be minutes because it was in the minutes spot. But the question says, so how many hours and minutes would this be? Well, because there's 60 minutes in an hour, this would be 1 hour, and what's left over would be 33, and I'm going to leave it as 0.75, 3/4 of a minute. It doesn't tell me to change it to seconds. If it had, it would be 1 hour, 33 minutes, and 3/4 of a minute would be 45 seconds, but I'm going to leave it as you see it on your screen. Let's look at an algebraic example of a proportion where we have multiple letters here. We need to find the value of x. So again, my cross product equation would be 9x. But when I do the right side, I'm going to have 3 times all of x minus 4. So hopefully you recognize here that you're going to have to distribute on the right side to get 9x equals 3x minus 12. And now we need to isolate our variable by subtracting 3x, getting your variables on the same side, getting 6x equals negative 12. Then finally, divide each side by 6, and x equals negative 2. You could verify that this works by plugging negative 2 back into the original proportion and seeing that you get the same value on either side. Okay, again, in letter B, find your cross product equation. 11 times the quantity of w plus 24. And again, I'm going to need to distribute to get rid of my parentheses. 33w equals 11w plus 264. I'm going to combine my like terms, meaning I need to subtract 11w from each side, which gives me 22w equals 264. Divide each side by 22 for a final answer of w equals 12. Okay. Finally, some real-life examples of proportions and where they can be used would be with scale drawings and scale models. And these are just either two-dimensional drawings or 3D models of objects in which the actual dimensions are in scale with the drawing or the model. Some examples of these would be architectural blueprints, and maps would be examples of scale drawings, and then scale models would be some of the cars that you assemble. If you look in the corner of the box, it always tells you the scale, which means if it says 1 to 24, every 1 unit on the model is equivalent to 24 units on the actual object. So let's look at an example of a scale drawing and show you how proportions can be used to figure this out. On the blueprint above, the living room is 1.75 inches by 1.25 inches. Use proportions to determine the actual dimensions of the living room. Okay, based on this, I know that I'm going to have to do 2 proportions. Because when it talks about dimensions, I'm going to need to find the length and the width. So I'm going to do 2 separate ones here. I'm going to set up my proportion, and I'm going to use the scale, which is here in the corner, and the scale is always given as the scale measure to the actual measure. So I'm going to say 1 is to 12, and this is 1 inch to 12 feet, as well, if I'm told that the living room is 1.75 inches, since I'm putting inches on the top, it has to go on the top. And I'm going to actually put an L down here in the bottom so I know its length. So I'm going to find my cross product. 1 times L is L equals 12 times 1.75 would be 21. And it's going to be feet because if we remember it was inches to feet. So the length of the living room would be 21 feet. And I'm going to set up a second proportion for the width. Again, the scale is one side of it, 1 to 12, and it's inches to feet. As 1.25 inches is to the width. Now that I have my proportion, I cross multiply. 1 times W is just W, and 12 times 1.25 is 15. So the width is 15 feet. So the dimensions of the room are 21 feet by 15 feet. So having the ability to use a proportion is extremely important if you end up doing any type of construction work or go on to college to become an architect. All right, so hopefully you now recognize that being able to identify ratios in a problem are the key to knowing that you can write and then solve a proportion to figure out the answer.